Tensees, we meet again in the world of linear relations and functions. This lesson will be looking at graphing relations. Now, graphing is something you've done before. In the first lesson of this chapter, we talked about how relations can be in all kinds of forms. We started with ordered pairs, and the ordered pairs lent itself to a table of values. Table of values and ordered pairs both allow us to graph something. And from graphing, well, or all of this, graphs, ordered pairs, table of values, this can all be described with equations or in word form. So this is the relation for linear relations. Today we're going to focus on the graphing relations. Something you've done in the past. And for you coming out of junior high, table of values, ordered pairs lead to graphs. And we'll do a quick review of that, and we're going to add another way to graph as well with some new terminology that again is going to be important moving forward in your math career. So if you're at page 29 of the booklet, what we have here is we have two examples on that page, and then on page 30 we have a third example. Well, I got to be honest with you, examples 1 and 2, even though it says something different, it's really the same thing. We can graph using any 2 points on the graph. We just have to find those. We can graph using a table of values. A table of values helps us to find points on the graph. So the two are very closely related. We'll take a look at an example of each. So to start with, page 29, using any 2 points on the graph. The first examples there is we want to graph the equation y equals 2x minus 1. Now with that, it's showing a relation between our y and our x values. Well, how can we come up with that? Well, really, we create a table of values. We know we're starting with x values. We know that the x value will be used in the equation 2x minus 1 to give us our resultant y value. So in this case, question tells us to use x is negative 4. Well, how do we come up with the y value? 2 times negative 4 minus 1. 2 times negative 4 is negative 8. Negative 8 minus 1 is a negative 9. So we have our first point. Table of values lends itself to an ordered pair. So our first ordered pair is negative 4, negative 9. So on my Cartesian grid, negative 4 from the origin is 4 to the left and 9 down. There's our first point for the relation y equals 2x minus 1. Now the second one is I want to use x equal to 3. So if x is equal to 3, that's using the relation. We have 2 times x, which is now 3 minus 1. 6 minus 1 is 5. So we have 3, 5 as our next ordered pair. 3 to the right, 5 up. There are the 2 points on the graph that we can use to create the graph for the relation or equation y equals 2x minus 1. Now, you should always do this with a straight edge. Unfortunately, I don't have a straight edge. Well, maybe I do have a straight edge on my smartboard. Let's see if this will work. I can draw a line through those 2 points. And I can make it fairly accurate. There we go. So there's the graph. Because it's a linear graph and goes forever, we should have arrows on the ends to say that it's going forever. And there's the graph we have for y equals 2x minus 1. Now, note that it says any 2 points on the graph. Those 2 points, the first point and the second point, allow me to connect them. I personally don't like using 2 points. My suggestion is to always use 3 points. Because if I make an error with one of those first 2 points, let's say I make a little silly error and point 1's supposed to be here, well, that's going to be a different line. If I were to move it over to here, it's a different line. So my suggestion is I always like to use 3 points minimum just to double check. So I've used x is -4, I've used x is 3. Let's find something in the middle and see if it lines up how we're hoping. So if I were to say use x equal to 0, and I were to plug into that, if x equals 0, I can go 2 times 0 minus 1. 0 minus 1 is a -1. So 0, -1 is a third point. If I graph from 0, -1, there's that third point which is on the line, which it should be. And the great thing is it's on the line, so I do have the correct line. 2 points is technically all you need. 3 or more points just confirms that you have the right line. So that's one way to make a graph. Now, if we look at example 3 on page 30 using a table of values, well, really, it's the exact same thing as what we just did. Except this time, with this table of values, x, our equation, will give us a y and give us our ordered pair. It doesn't tell us what to use. I can use whatever I want in here. Now, on page 30, number 3, it actually does give us 3 points. You only need 2, but 3 confirms things. So in that case, it actually gives us points to use for x. It gives us -2, 0, and 2. Now, the work that we do will probably, our graphs are all going to revolve around the origin. They're all going to be in that sort of space. So you want to pick points for x that are around there. And since y is dependent on x, because we put x in first, can make the calculations with it, y is dependent on that. Putting in values for y is a lot more efficient than putting in values for x. So if I use x -2, well, -2 times -2, subtract 5. -2 times -2 is 4. 4 minus 5 is -1. So we end up with -2, -1 is a point. Now I can use my second x value of 0. -2 times 0 minus 5. -2 times 0 is 0. 0 minus 5 is -5. So we have 0, -5. And now, those 2 points, -2, -1, and 0, -5, those are enough points if I want to draw my graph. I can draw it. However, do we know for sure we're correct? We don't. If one of those points is off, sure, it looks like it makes sense, but using that third point, -2 times, now we're using 2 as x, -2 times 2 is -4, -4 minus 5 is a -9, we end up at 2, -9. So let's finish that one. -2, and then 1, 2, 3, 4, 5, 6, 7, 8, 9 down. There's -2, or sorry, 2, -9. It's on our line. 3 points confirms we have the right line. This is not new for you. You have seen table of values, ordered pairs before to make graphs. Make sure that our assumption is that all of our tables are where x is a member of the reals. And reals meaning all decimal and fractional values. So we want every point. And that's why the solid line was used to graph instead of dots, because we will assume we're always graphing real values unless a question states otherwise. We can make that assumption. Well, back to page 29, and let's take a look at the second way we can make a graph, and that's using x and y intercepts. X and y intercepts to start with. What is an x and a y intercept? Well, x and y intercept are the points where a graph intersects the x-axis and the y-axis. That's what intercepts are. Where do we intersect the x-axis? That would be the x-intercept. Where do we intersect the y-axis? That would be the y-intercept. So if I had some graph on here, there's a graph I created, a linear function. Well, what we have, our x-axis is where we hit, or sorry, x-intercept is where we hit the x-axis. There's your x-intercept. Because that's the x-axis, there's your x-intercept. Where we intersect the y-axis is the y-intercept. So that would be our y-intercept. And the x-intercept and y-intercept essentially give you 2 points. And as long as you have 2 points, you can create the graph. So that's what we're going to look at. But the last bit that's so important to an x and a y intercept is understand an x-axis, sorry, not x-axis, it hits the x-axis. The x-intercept, what do we know? Any point that hits the x-axis, what do we know about that? Well, if there's any point on the x-axis, doesn't matter where it is. What do we know? We know that we haven't moved up or down. Every x-intercept has a y value equal to 0. The only way to hit the x-axis is if y is 0 because we're not moving up or down. And so then the second part to that is a y-intercept. What do we know about any y-intercept? Any point on the y-axis that intersects. How do we intersect on the y-axis? Well, we don't move left or right, which means our x value will always be 0 for a y-intercept. So we'll use that and take a look at what that means. Let's take a look at the example that's there. Use the x and y intercepts to graph y equals negative 2x plus 6. So here's our graph. I need 2 points. I'm going to use the x-intercept, and I'm going to use the y-intercept. Well, the key is, I just talked about it. If we're going to somehow intersect the x-axis for our x-intercept, what do we know? We know our y is 0. We haven't moved up or down if we're on the x-axis. So that means I can take my equation and y has to be 0. So my y is 0 for negative 2x plus 6. And now I can solve for x. Algebraically, subtract 6, divide by negative 2, and we get 3 as our x value. What does that tell us? That gives us the x-intercept. X is 3 when y is 0. There's the x-intercept, which makes sense. At 3, 0, 3 to the right, 0 up and down, we are intersecting the x-axis. And that's what we wanted to do. The y-intercept, in order to contact somewhere on the y-axis, what do we know? We haven't moved left or right. So that tells us that in order to have a y-intercept, x must be 0. So I'm going to take my equation And this time, use x equal to 0. So we have y is equal to negative 2 times 0 plus 6. Negative 2 times 0 is 0 plus 6. Y is equal to 6. So what's the y-intercept? Well, we get a value of 6 for y when x is 0. X is 0, y is 6. We have 0, 6. So 0 and then 6. There's the y-intercept. 2 points. Now I can connect those. X-intercept, y-intercept. Connect those. Make a small adjustment to it. And there you go. And again, goes forever. And we have her done. Now in this case, we might want to check that we have the correct value. That's only 2 points. Again, maybe we made a mistake. I've finished it. I've used the x and y-intercept like it says. But me being the uptight math guy, I'm going to double check it, and I'm going to use x equal to, let's just say 6, and see what I end up with. Y equals negative 2 times 6 plus 6. That'll give me negative 12 plus 6 is negative 6. So x is 6, y is negative 6. This is just me picking a third point to make sure it works. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, negative 6. Well, we're not quite there. But if I really wanted to be picky, make sure that I'm going through. I can see the x-intercept maybe isn't quite where it should be. So there you go. Pretty close. We can assume that now we have the correct graph with the correct intercepts. X-intercept, y-intercept. When y equals 0, when x equals 0. It gives us 2 points, and technically 2 points is all we need to graph. So, page 30, a couple more examples. Graph each function using the technique asked for. Here we go. It says graph using 2 points. So if we have y equals 2x minus 6, I need 2 points. I need 2 x's that I can use as my independent values to get my y's. Don't use points. I wouldn't use like x1 and x2. Spread them out a bit so that I don't have points right beside each other on the graph. Pick points that'll be spread out a bit so we have a little bit more difference when I connect points. So let's maybe try x, negative 2, positive 2. Spread out a little bit, still around the origin. So in this case, we would have y equals 2 times negative 2 subtract 6. What do we get? Negative 4 minus 6 is a negative 10. So when x is negative 2, y is negative 10. And now I can plug in x equal to 2 for my second point. Y equals 2 times 2 minus 6. 4 minus 6. Y is negative 2. So we have the point 2, negative 2. We get 2 points. Check it, negative 2, negative 10. And then we have point 2, negative 2. And there's where we can connect. With a line, there's our graph. Add arrows to say that it's going forever in both directions. And there we go. 2 points. Could we check with a third? Absolutely. Let's check with, I don't know, x equal to 4. One more point to use. Y equals 2 times 4 minus 6. 8 minus 6 is 2. So as a quick check, even though it only says using 2 points, I want to make sure I'm correct. So at y equal to 2, at x equal to 2, what am I doing here? I apologize. X equals 4, y equals 2. 1, 2, 3, 4, 1, 2. Look at that. right on the line which it should be. A quick verification of the 2 points I used. You've seen that process before. But let's take a look at example 2 there on that page. Graphing 3x plus y equals 9, x and y intercept. X-intercept, what do we know? If we hit the x-axis, our y value has to be 0. We haven't moved up or down. But to hit the y-intercept, y-axis, our x has to be 0 because we haven't moved right or left. Those are the 2 values that I'm going to use to come up with my points. So, using the equation, for the first x-intercept, y is 0. 3x plus 0 equals 9. Well, 0 just doesn't exist. Divide by 3, x equals 3, so we have x equal to 3 when y is 0. Our our y-intercept occurs when x equals 0, so we can now substitute that into the equation. 3 times 0, because that's our x value, plus y equals 9. 3 times 0 is 0, just disappears. Therefore, y equals 9. When x is 0, y is 9. There's your y-intercept. X-intercept, 3, 0. Y-intercept, 0, 9. Connect those, nice straight line, and we will have our correct graph. Fix that up a little bit so it's nice for both of those axes. Make sure you put your arrows on to say that it goes forever in both directions. X-intercept and y-intercept allow you to make a graph. Last one. Turn off the video, give this one a try, see what you come up with. So, x and y intercepts. X-intercept occurs when y equals 0. So we take the equation, and I'm going to plug 7x plus 3 times y, which is now 0, plus 9 equals 0. We solve for x. So in this case, when we do this, we get the 3 times 0 just disappears because it's a 0. So I subtract 9 from both sides. I get 7x equals negative 9. Divide by 7. X equals negative 9/7. Which if I convert to a mixed form, because it'll be easier to graph, we end up with a negative 1 and 2/7. Now obviously, I can't be exact on this, but as long as I graph it somewhat accurate, I'll be okay. So what's our x-intercept? Negative 1 and 2/7 when y is 0. Our y-intercept occurs when x equals 0. So again, substituting in 7 times 0 plus 3y plus 9 equals 0. 7 times 0 just kind of disappears because that's a 0. Subtract 9 from both sides. 3y equals negative 9. Divide by 3. And y is negative 3. So our y-intercept, when x is 0, y is negative 3. So I graph my two intercepts. Negative 1 and a little bit. So that's a rough estimate that's acceptable. And 0, negative 3. There's my second point. Those points are fairly close together, but I can still connect them, absolutely, to create a line. So I just connect those 2 points, my x and y intercepts, and there is my function graphed, my relation graphed using x and y intercepts. Your assignment booklet, page 31 and 32, there are questions in practice in our booklet that you're working in right now as well. Textbook, page 308, number 6, asks you to graph. It doesn't tell you how to graph, but you need to be familiar with all of the types. So try the different processes, whether it's using points or the X and Y intercepts when you're doing it. The only way to get good at it is to practice. Have fun.